Yes, welcome to all. In today's lecture, we are going to discuss the point related to the regular expression, that is how to convert the given regular expression into its equivalent finite meta. Here in this diagram, it will show the relationship between finite meta and regular expression. So here you can see we can convert the given regular expression into its equivalent NFA without epsilon moves, or we can convert it to the NFA without epsilon moves, as well as we can convert the given regular expression into deterministic finite meta. So we know that regular expression, so we represent the given regular language in the compact form by using three set of operators, that is dot, star and plus. So that compact form is called as regular expression. Now one more point related to the regular expression is what recursive nature of the regular expression. Now what do you mean by recursive nature of regular expression? So here you can see the given regular expression. Here one regular expression is given, r is equal to 1 plus 0 1 0 star dot star. So there is a concatenation operator. There is a concatenation operator between these two regular expressions. One dot. There is a concatenation operator. There is union operator between 1 and this another regular expression. And again one more concatenation operator between 0 and this regular expression. So what we are going to do here in the recursive nature of regular expression, we are going to divide the given regular expression into number of sub-regular expression, or we are going to split it. So here the given regular expression, let us say r, will be equal to p star. So p star means what? So this remaining p is nothing but, so here I have represent p is nothing but 1 plus 0 1 0 star. Okay, and if you take its closure, star closure, then it will be p star. Further, p can be written as, so there is a union between 1 and remaining this. So that's why p can be written as p1 plus p2. Plus operator represent union operator, where p1 is nothing but, so p1 is what? So p1 is nothing but this one, and p2 is nothing but this remaining part. So that's why p1 is equal to 1 and p2 is nothing but 0.10 star. Now we cannot split p1 into number of regular expression, but p2 will be, we can split p2 into number of regular expressions. So that's why why? Because there is concatenation operator between 0 and 10 star. So p2, further p2 can be written as p3 dot p4. And what do you mean by p3? p3 is equal to this 0 and p4 is nothing but 10 star. Now again we can divide that p4 into number of regular expression, because there is a concatenation operator between 1 and 0. So p4 can be written as, so p4 denoted as 10 star, yes, p4 further can be written as p5 10 star, and p5 can be written as p6 dot p7, where p6 is nothing but 1 and p7 is nothing but 0. So this is called as recursive nature of the given regular expression, and once we will combine all these, we will get the original regular expression, means like this: p dot p6 p dot p6 dot p7 is nothing but p5. Okay, and if we will take its closure, then it will be p4. Okay, so it will be further p5 can be p4 star. Okay, and now p4 dot p3, if we will combine these two, so we will get p2, and if we will add that p2 with p1, so we will get p. Okay, and if we will take the closure of the p, then we will get r. So r is nothing but p star, and p is what? 1 plus 0 1 0 star, and if we will take its closure, then we will get the given regular expression. So this is the concept related to recursive nature of the given regular expression. Now how to convert the given regular expression into its equivalent finite meta? So there are total two rules are there. Okay, one is basis or zero operator rule, and second one is nothing but the induction. Second one is nothing but the induction rule. Okay, so firstly we will see basis or zero operator rule. Now let us consider r since R as a zero operator. Zero means what? Either it will be epsilon, given regular expression is equal to epsilon, or given regular expression is equal to phi, or given regular expression is equal to A. A represent any input alphabet or any regular expression. It may be single A, it may be single B, it may be 0, it may be 1, it may be any input alphabet. So its equivalent phi and data is nothing but, suppose given regular expression is equal to epsilon, then its equivalent regular expression is equal to this Q0 itself or initial state itself or final state, means it will be like this. So initial state, we know that how to represent initial state by using arrow, okay, and single circle we are going to represent initial state. And initial state, as there is a regular expression is equal to epsilon, so initial state itself or final state, means whatever input alphabets are there, we will be in the final state. Now second one is nothing but regular expression equal to phi. So in that case there is no any path from initial state to the final state. So here you can see Q0 is the initial state, okay, Q0 is the initial state, and there is no any path from Q0 to QF, where QF which we have represented by the double circle, and QF is the final state. So here there is no any path from Q0 to QF. And now if the given regular expression is equal to A, okay, suppose A is the regular expression, so from initial state after accepting A it will be in the final state. From initial state after accepting A it will be in the final state. Q0 after accepting A it will be in Q final state. So these this basis rule indicate that if we are having RE is equal to epsilon, then Q0 or initial state itself a final state. If RE is equal to phi, RE is nothing but regular expression. If it is equal to phi, so there is no any path from initial state to final state. And if RE is equal to A, then from initial state after accepting A it will be in the final state. Now how to now second rule is nothing but induction rule, which will in that case we are having the regular expression n is greater than equal to 1. Previously you can see it is equal to 1 or less than 1. If it is 0 or if it is 1 or it is epsilon, then its equivalent phi data is like this. But now if n is greater than equal to 1, then how we are going to represent the given regular expression into its equivalent phi data? So there are total three possible rules are there in case of induction. One is union rule, second one is the concatenation rule, and third one is the closure rule. So firstly we will see union rule. So if union, in case of union case, if R is equal to R1 plus R2, where R1 is the one regular expression, R2 is another regular expression, and if you take its union, then how to draw its equivalent phi data? So its equivalent phi data for this diagram is there. So Q0 is the initial state, Q0 after accepting epsilon it will be in Q1 state, as well as it is in Q3 state. So R1 is one path and R2 is another path. So Q0 after accepting epsilon it will be in Q1, after accepting R1 it will be in Q2, after accepting epsilon it will be in the Q final state. This is first part for R1. Okay, and for R2, Q0 after accepting epsilon it will be in Q3, after accepting R2 it will be in Q4, and after accepting epsilon it will be in Q final state. So this is second part. Okay, so this is the union case. Now second one is the concatenation case. In case of concatenation, we are going to join that two. So R1 dot R2, where R1 and R2 are the two different regular expressions. Means after R1 we are having R2. Here in case of this R1 plus R2, either we are going to follow this path or we are going to follow this path. That's why it is a union. Q0 after accepting R1 also we are in the final state, or after accepting R2 we are in the Q final state. But in case of concatenation, after R1 we must have R2, then only we are in the final state. That's why Q0 after accepting R1 we are in Q1, after accepting epsilon we are in Q2. Why? There must be some concatenation. So if there is no any input alphabet, still we are in the Q2 state, and from Q2 R2 will start, and that time after accepting R2 we are in the Q final state. So this is the regular this is the phi data for the given regular expression if there is a concatenation operation between two regular expression. Now suppose third one possible induction rule is what? Closure, means R is equal to R1 star. So we want to take its star or plane closure. Then how to write down its regular expression? How to convert this type of regular expression into phi data? For that, here you can see R is equal to R1 star. So Q0 is the initial state. After accepting epsilon we are in Q1 state, after accepting R1, the given regular expression, we are in Q2 state, and as there is a star, means we have to repeat this part n number of times. It may be one time, it may be two times, it may be n number of times. That's why we are going to repeat this, okay, with epsilon input. We are going to repeat this with epsilon input. Suppose R1 is equal to A, and A we have to A star is there, where A consists of string triple A. Means we want to repeat that A 3 times. Then how we are going to represent? So Q0 epsilon, first A, repeat, second A, third A, and after that we are in the final state. And suppose, as I said that it's a star closure, okay. So if we don't have any input output, that time it will be epsilon. Still it should be accepted. That's why from Q0 to final state, after accepting epsilon, directly we are in the final state. So there must be path. If R is equal to only R1 plus is there, positive closure of the given regular expression, it may be A plus, that time this path will not be there. Directly we must have at least one A must be there, so this path will be followed. But if star is there may be the case we may have 0 number of A's or given input alphabet, that time we directly are in the Q3 state or Q final state. So these are the number of rules. So we have discussed up till now 2 rules. One is zero operator rules or basis rule, which will consist of RE is equal to epsilon, or RE is equal to phi, or RE is equal to A, and these are the its equivalent phi and automata. And second rule is nothing but the induction rule, which will consist of again 3 sub rules. Union rule. In case of union rule, R1 and R2 are the 2 regular expression, and if you want to take its union, means either we are going to follow this path or this path. Okay, so in case of R1 path, we are going to follow this path. In case of R2, this will be there, because there is a union operator. But in case of concatenation, we must have to follow after R1 only, R2 will be there. So R1, epsilon, and R2, and epsilon is nothing but the it will going to connect that 2 regular expression. And again one more regular expression is one more rule is nothing but closure rule. So in case of closure rule, R1 star is there, so we have to repeat this part. Okay. And if in that case if epsilon is there, then directly Q0 to Q final, there is a epsilon path is there, and we are going to reach to the final state. Now we are going to solve one problem based on how to convert RE to NFA with epsilon. So here you can see we want to draw B plus BA star. So given regular expression is B plus BA star. This is the given regular expression, B plus BA star. And now we want to convert it into its equivalent NFA with epsilon, or into its equivalent phi intermediate in short. So first of all, we know that we have to divide the given regular expression into number of sub-regular expression. Here we are going to apply recursive nature of the regular expression. So here you can see there is a union operator between B and BA star. So I am going to divide the given regular expression R into like this, R1 plus R2. So R1 is nothing but B, and R2 is nothing but BA star. So we have applied the recursive nature of the given regular expression, and we have divided that given regular expression into 2 sub-regular expression, that is R1 plus R2, because there is a union operator between B and BA star, where R1 is nothing but B and R2 is nothing but BA star. Now R2 further can be written as, so again R2 we can divide it as a this B dot A star, because there is concatenation operator. So B is nothing but R3 dot R4, where R3 is nothing but B, R4 is nothing but A star. Now further dividation is not possible for R3 and R4. So now we are going to draw separate regular expression, separate finite automata for each regular expression. So R1 is what? R1 is nothing but B, R3 is nothing but B, and R4 is nothing but A star. So we will draw the regular expression, we will draw the finite automata for each regular expression. So first one is NFA for R1 is equal to B. So R1 is equal to B means here we need to apply zero operator rule or basis rule, because in case of, so for the given rule is what? Here you can see basis rule indicate that if RE is equal to A is there, so Q0 after accepting A, it will be in Q final state. So here in this case we are having R1 is equal to B, so that's why Q0 after accepting, Q0 is the initial state, okay, Q0 after accepting the given B, okay, given regular expression, that is B, as it is zero operator rule, we are in Q final state, or let us say we are in Q1 state, and Q1 is the final state for first regular expression R1. So here you can see here, okay, R1 Q1 after accepting B, it will be in Q2. See, here you can change the naming convention. It may be, you can start with Q1, you can start with Q2, you can start with Q0. So this is for first regular expression. Now for second regular expression, R2 is equal to BA star. But further we have divided that BA star as a R3 and R4. So where R3 is nothing but B and R4 is nothing but A star. So R3 is equal to B. So again here we need to apply the zero operator or basis rule, because again there is a single operator is there or single regular expression is there. So Q3, previously we are in Q2, that's why here we have renamed it as Q3. Q3 is the initial state for R3. So Q3 after accepting B, it will be in Q final state, means Q4 is the final state in case of this R3 regular expression. So Q3 after accepting B, we are in Q4 state. Now Q4 means what? A star. So A star means here we need to apply the star or clean closure rule. So we know that star or clean closure rule, okay, in case of induction. So Q5 is the initial state for this R4. After accepting epsilon, we are in Q6 and after accepting A, we are in Q7, and this part is repeated. So we will going to apply that rule. So already we have seen this closure rule. Okay, same. Instead of R1, here we are having A. Okay, in the given regular expression, instead of R1, here we are having A. So we have written A, and this part is repeated. As there is a star, so there must be initial path from initial state to the final state, means Q5 to Q8. Now after that, what we have drawn the finite automata for R3, we have drawn the finite automata for R4. Now we have to find out for R2. So how to find out for R2? We need to find out, perform the concatenation between R3 dot R4. So R3 is B, R4 is A star. So I am going to join these two. See here, I am going to join these two according to concatenation rule. Concatenation is what? So concatenation rule indicate that we have to join R1 and R2, and there must be epsilon between R1 and R2. Okay, so same way here we need to apply the concatenation between R3 and R4, which will going to form the R2, because R3 is B and R4 is A star. So I am going to apply the concatenation rule between these two. So I am going to join these two. Okay, so I am going to specify epsilon. Now this will not be a initial final state. Here it will be intermediate state, means Q3. After that, after accepting B, it will be in Q4, means R3 is over, and after accepting epsilon, it will be in Q5. Now Q5 is not initial state, it will be intermediate state. After that, it will be epsilon, means this is R4, means B dot A star. So this will be R2. So here you can see we have joined that two. Here this one is R4. Okay, we have joined that. This is R1. Sorry, this is R3 dot means epsilon, and this is R4, and which will going to form the R2 B A star. This is A star part, and we have joined that Q3 dot Q3 after accepting B, it will be in Q4. After that dot, it will be in Q5. After that it will be in Q6. Okay, after that this part is repeated, and now we are in Q8. Now we know that the given regular expression, we need to take the R1 plus R2. So already we have find out R2. Okay, R2 is like this. We have to take the union. Means now we need to start like this Q0. Okay, and we have to point out that R1. So already R1 is what? R1 is nothing but A is there. Sorry, B is there. Right? R1 is this one. So we have to join this part. We have to perform the union with this one. So here you can see this one is nothing but the R1. This is first part. Okay, and this is nothing but the R2, this is the second part. We have taken its union, and this is nothing but the final NFA. Q0 epsilon B. Okay, this epsilon, it will be in Q final state, and this will be union, because according to union rule, here we have applied this union rule. Okay, this is the union rule. This is the R1 part. R1 is nothing but B, and R2 is nothing but B A star. So we have taken its union, and we have written it. So here this one is the final NFA B A star. This is B, and there is union. So either we are going to follow this path or this path, as there is a union operator between these two. So this is nothing but the final regular expression. In this way, we can convert the given regular expression into NFA with epsilon. This is another example. In this another example, you can see here, construct NFA with epsilon with for regular expression. So given regular expression is 0 plus 1 star. So there is a union rule between 0 and 1, and after that we have to take its clean closure. So first of all, we will draw R1 plus R2. So here you can see R1 plus R2. So if we'll draw it R1 plus R2, I'll draw it separately. So R1 is what? 0 and R2 is 1. So we have to take its union. Okay. So here it will be, let us say, initial state. I'll firstly draw the R1 plus R2 and after that we'll take its closure. So Q1 after accepting epsilon, it will be in Q2. After that R2. Okay, R2 is what? R1 is what? 0. So it will be 0. After that we are in Q3 state. After that, after accepting epsilon, we are in Q final state, or we can say that Q5 state. Q5 is the final state, so I'll show it by using double circle. Now second one is 0 is what? Second one is 1, means R2. So there is a union. So again there is epsilon. We need to follow. This one is Q5. So I'll rename it as Q6. Okay. After accepting 1, it will be in Q7. And after accepting epsilon, it will be in the Q final state. Okay. So this is R1 plus R2, and after that we have to take its clean closure. So I'll going to repeat this part. So it will be Q0 initial state. Okay, and let us say Q final state or Q7, whatever it may be. Okay, Q final state, and there is a path from initial state to the final state, and now this one will be intermediate state. So same here we have shown you. Here you can see here. This one is nothing but the Q0, Q1 after accepting epsilon, it will be in Q2, 0, Q3, and we are in Q6 state. Same way for one part we are in Q6 state, and we have to take its clean closure. That's why I have repeated this part. And from Q0 to Q7 there is a path. So this is another example related to how to convert regular expression into NFA with epsilon. This is one more example is there. So in same previous example, 0 1 1 0 plus is there. So 0 1 path, 1 0 path is there. We have to repeat this part, but there is a positive closure. That's why we have not shown the initial state to the final state with epsilon. As there is a positive closure, means we have to take this part at least one time. So this is nothing but the final final derivative for the given regular expression. Okay. Construct the NFA for the language having odd number of zeros over the set 0 1. So first of all, you need to write down the regular expression for the given NFA with epsilon. For the given language, and after that you have to convert NFA with epsilon. So we know that how to write down the regular expression, which will consist of the odd number of zeros. Odd number of 0.00 star. Odd means it will be single 0, 3 0, 5 0, 7 0 like this. Okay. So 0.00 bracket star. This is the regular expression for the given language. Now we want to convert it into its equivalent NFA with epsilon, or its equivalent 500 meta. So there is a concatenation operator between first and second part. So that's why I have written that given regular expression into we have applied its recursive nature. So R1 dot R2, where R1 is 0 and R2 is 0 0 star. Okay. Further, so its equivalent final NFA will be like this. So Q0 after accepting 0, it will be in Q1. Okay, because we want to write down for 0.00 star. 00 bracket star. Okay. So there is a concatenation operator. So this is R1 dot means epsilon, and now 00 star. So this part is repeated 00 star. Okay. And after that from initial to final there is a path. So Q0 to Q7. This is nothing but the final NFA for the given regular expression. Thank you.